Good morning to all. Myself P.Mahesh Krishna, working as Assistant Professor in Department of Mechanical Engineering in Swarnandhra College of Engineering and Technology. And now I need to give the lecture on TOM subject, so that is theory of machines. And I taken the topic is inversions of a mechanism. So first let us discuss about the what is meant by a mechanism. Suppose if you consider a particular kinematic chain, so if you fix one of the link of a particular kinematic chain and if you transmit the motion between the particular links, so then we can form the mechanism. And based on the different types of mechanisms, so we have 4-per chain is the main mechanism. So let us consider the inversions of a mechanism. So already I informed that so fixing of the particular link of the kinematic chain represents the one mechanism. Suppose if we are changing the particular fixing of the link to the next link means, so then we can form the inversions of the particular mechanism. So coming to the inversions, the process of fixing the links of a kinematic chain in such a way that one link is fixed at a time to get the different mechanisms. So these are the, let us consider a 4-bar mechanism. Okay, so first figure shows the 4 links which are connected in turning pairs. Next, if we fix the first link means, so which is beside the shortest link, so then we can get the one type of mechanism. So that type of mechanism is represented as crank and slaughter lever mechanism. And second one, if we consider the crank as the fixed link, so then we can get the double crank mechanism. And third one, if you fix the third link, so that is considered as the connecting rod. So if you fix the connecting rod, then we can get the double single slider and crank mechanism. And fourth one, if you fix the link which is opposite to the second link, so that is shortest link, then we can get the double rocker mechanism. So this mechanism can be represented in the next slide. So this one. So here we need to consider the 4-bar mechanism. So first one, we are having the longest link, that is longest link which is represented by letter L, and shortest link which is represented by S, and 2 intermediate links P and Q. Okay. So initially to construct this particular type of mechanism, so we need to follow the Grashopp's law, so which states that the sum of the shortest and longest link lengths should be less than or equal to the sum of the other 2 link lengths. Okay. So now by considering the shortest link, so we need to fix the different types of links. So based on that, each inversions will be developed. Suppose if you fix the longest link and if you rotate the shortest link means, so then the shortest link will be rotated in completely circular direction. So that represents the crank rotation. Next, based on this particular input, we get the output as the rocker motion. So that is the oscillating motion. Next one, same type. If you consider the link which is opposite to the link which is beside to the shortest link, so then that particular mechanism also represents the same motion. And if you consider the shortest link as the fixed link, so then we will have the 2 types of motions which represents the double crank mechanism. So that means both P and longest link will completely rotate and make the mechanism. And if the link which is opposite to the shortest link, if you fix that link means, so we will get the oscillating motion. So that represents the double rocker mechanism. So this is the criteria which we need to follow for the construction of the 4-bar mechanism. So based on the Grashopp's law, so we need to state that the sum of the shortest and longest link lengths will be less than or equal to other 2 intermediate links. And already we have discussed that, so the link which is completely rotating makes the crank and it is also known as the driver. And if the link which is oscillating or moving at an angle means, so that represents the rocker and also known as lever or follower. So coming to the inversions of the particular mechanism, so we have 3 different types of kinematic chains. So one is 4-bar kinematic chain, second one single slider crank chain, and third one double slider crank chain. So here we can observe the certain animations of the particular inversions. So this represents the double crank mechanisms where shortest link will be shortest link will be fixed one and remaining two links will be completely rotated. And in this particular case, we can develop the double rocker mechanism. So where it will make the oscillations. So the applications of these particular mechanisms are, one is wiper for the automobiles. So where we can consider the crank and rocker mechanism. So here the motor will be rotated and makes the crank rotation, and based on this particular link, so based on the connections of the other links, so the motion will be oscillating motion, so which represents the wiper motion, so that when the rain falls, automatically it wipes the particular raindrops. And we can observe this particular machine, so which way on the pedal we need to apply the particular force, so which creates the oscillating motion. So based on the flywheel motion, so it will be completely rotated and makes the crank motion. So here also oscillating motion is converted into the rotary motion. And these are the other applications for the crank and lever mechanisms. So this particular shaping machine, so that is for making the particular tools into sharper, so we need to use the grinder machine. So there also we need to apply the same mechanism where we need to apply the force on the particular pedal. So automatically this particular grinding will be rotated. So here also we need to apply the oscillating movement is converted into the rotary motion. And this crane will represent the motion of a double rocker mechanism. Next, so coming to the 4-bar mechanism applications. So first one, we have the first application as the beam engine, so which is also known as the crank and lever mechanism. And second one, coupling rod of locomotive, and third one, watt indicator. So coming to the beam engine, so it mainly consists of, the main application of the beam engine is to convert the rotary motion into the to and fro motion. So here coming to the construction, so it consists of the 4 links, and mainly the for the 4th link, so we need to consider extra link, so which is representing the sliding motion. So here the frame represents the fixed one. So you can so here we can observe the motion and also animation. So the first link which represents the frame, so that is the fixed link, and second AB represents the crank. So here we need to give the input to the crank, so which rotates the clockwise direction, and then third link which is represents the connecting rod, and fourth link oscillating link, so that represents the lever. So for the lever, so we additionally represents the connecting the piston and cylinder, which creates the sliding motion. Okay. So here you can observe the animation of the particular mechanism. So where rotary motion is converted into the linear motion. So this is the main application of the beam engine. And next one, coming to the locomotive, so that is double crank mechanism. So here we need to apply the 4-bar mechanism and having the same link lengths. So that means 2 links are having same equal length and remaining 2 links are in equal length. So here longest link, so that is link 1 is the fixed one, and AD and BC represents the crank motions, and CD represents the connecting rod. So here you can observe the motion of the particular wire wheel. So the wheels, the center of the wheels is known as the fixed support, and based on this particular cranks and connecting rod, the motion will be transmitted from one wheel to the another wheel. And next one, coming to the last application of the Watt's 4-bar mechanism, so that is Watt's indicator mechanism. So here the main application of this mechanism is to identify the displacement of the piston. Suppose if you consider this particular complete arrangement in the particular engine means, so we cannot identify the displacement of the piston from the outside. So in order to find the displacement of the piston, so we need to arrange the links, which is we need to arrange the links outside of the particular engine, so that the displacement of point E can be clearly identified from the outside. So where we can identify the displacement of the piston where it is happening in the inside. So in order to identify that, we need to construct this particular mechanism. So it mainly consists of one cylinder and piston. So DFT. So this particular complete link will act as a single link. And here the crank will be considered as the AC and CDE. So that link will be represented as the output link. Okay. So once if we displace this particular AC means, so C moves to the C dash point, and also E represents to the E dash point. So there we can identify the displacement of the particular piston. And next, same type of application we can use in the automobiles, where it can be used for the suspension system. So here also same watt mechanism, but it consists of two fixed links, fixed link and two connecting rods. Next one is the crank. Okay. So once if you hold this particular point P, so we can trace the particular path of the particular point P, so which represents the approximate path. Okay. So that means approximate straight line you can generate. So once the load is applied on that particular mechanism, so automatically it observe the vibrations and control the smooth movement of the particular vehicle. Okay.